Welcome to our web development class. In this class, we will look at Chapter 3, Fluid Layouts, Images, and Grids. We are talking about responsive web design, which provides a layout and a functionality that responds to the screen size. There is no need for server processing. This happens on the web page, on the client side. Responsive design components consist of the viewport meta tag and media queries. They were covered in our last class, Chapter 1 and 2. In this class, we will look at fluid layouts, also fluid grids, and flexible images. A typical web page layout is created in pixels, especially for the desktop. For example, very commonly we have the outer wrapper, outer container, with a very popular common width of 960 pixels. For example, we may have a header underneath that might be a little bit less wide. For example, maybe 940 pixels. We might have a margin set. We might have some padding set. Notice that they're all in pixel values. We might have a content area. Here again, a width set in pixel values, margin set in pixel values, also some other CSS properties such as floating. We do not want to use our media query to change the pixel measurements for different devices. What we want to do is to change the layout using percents. By using percents in our media queries, we will gradually shift from one state to another rather than have an abrupt change. In order to do this, we need a fluid and proportional layout. There is a very popular formula that allows us to figure out how to convert our fixed pixel width to percents so that they will scale gracefully for the smaller devices. This rule is target divided by context equals result. Looking at the rule, the context is the outermost container. It might be the outermost wrapper, or it could be another container that contains other elements, and we want to get the percentage of the elements inside it. The target is the pixel area of the area we want to change. By dividing these two, we will get a decimal, and then we can convert it to a percent. Usually you will get a decimal because we're generally going from larger to smaller. And by using this formula, everywhere we have a pixel value, we can almost guarantee that our site will scale gracefully. Remember, we might need to also clear some floats and eliminate unneeded content. So let's take a look at how this formula might work. Assuming that we have an outer wrapper with a width of 960 pixels, and supposing we wanted to change that for a device such as a tablet that might have a width of 768. Our rule, target divided by context equals result, the context being 960, the target being our target area, 768. Doing the math gives us 0.8, converted to a percent is 80%. So in our media query, for that width, we would set the wrapper, the width, to 80%. Now remember, when you're converting to a smartphone, you always want your outer width to be 100%. They are small enough to begin with. You really don't need any extra margins on the right or left. So looking at the formula, looking at the code we saw earlier, let's calculate the width. And remember, whatever the width is of the outermost container, you can kind of assume that that's 100%. So let's take a look at the code we saw earlier. and we will use the formula to convert the widths. Now our outermost container is 960, and therefore we're going to assume that is the 100% that we're going to be scaling down what's inside it. So the header, which is 940, using our formula, 940 divided by 960 will give us 0.9791666, and we convert it to a percent. Do we need those decimals? Some people may say no, some people may say yes. It doesn't hurt to be 100% exact. Moving along to the content section, the width was originally 698. Using our formula, 698 divided by 960 equals 0.7270833, and we would convert that to a percent. You would do the rest. You would also do this for your margins and padding. I'm just not doing it here because I only want to show you certain examples. All right, so why are we doing this? We're doing this because this is what we're going to be using in our media queries. This is how we scale down for smaller devices, by using percents. And therefore, within a range, as the browser narrows, everything will dynamically just automatically resize. So if we had a media query for a minimum width of 600 pixels, meaning we're starting at 600 and scaling up, notice we would have another breakpoint somewhere. And if we would set the wrapper to 100% because it's a small device, we would set the header to 97% and the content to 72%. And that would look good on our smaller devices. Now, this formula works with typography also. However, you should be using EM measurements to begin with. But there may be times when you have pixels, and you would use the same rule to convert. So let's talk about how the browser works with pixels. Most browsers use 16 pixels as the standard font size. So the 16 pixel is actually the 100% size, which is what 1 EM is. EMs and percents are generally the same equivalent. So by setting the font size to 100% would be the same as setting the font size to 1 EM. So if we were to use our rule to get our percent, we would just change that over to an EM. Technically you can leave this percents, but most developers use EM. Alright, so let's take a look at our example here. Here we have a font size set to 48 pixels, and we wanted to change that to an EM. How would I figure out how to do that? Well, here is our rule. The target divided by context equals results. In this case, our context would be the default font size, which is 16. Remember, we're working in pixels. Now, the size that we're actually changing is 48. So we want to find out what that is percent-wise. So if we divided 48 by 16, we would get 3. 3 as a percent is 3%. Now, we don't want to use percent, although you could. We're going to use EM. Now remember, the percents and EMs are technically the same. So now we have the new font size of 3 EM that would scale nicely on all devices, retaining the same proportion that it has as a pixel. All right. We also have an issue with images. Even though we're scaling our text, scaling our widths, the images are going to stay the same, which is not going to look good. So how do we get around this? All right. The most easiest way that developers are using, and this isn't necessarily the most efficient or the most bandwidth saving, but it is what developers are using, is setting the max width property on the image to 100%. All right, that alone, that is good. That means that the image is going to be 100% of its default size wherever it is. One thing that you need to keep in mind is that in your HTML, you now have to remove the width and height, because that will take precedence over the style sheets. However, that in itself doesn't make our image responsive. What really makes our image responsive is that it's inside a container that is responsive. Remember, our containers have percent widths. So taking a look at the code below, if our image was inside the figure element and we wanted to make that image responsive by saying that the image can only be the maximum width of its container, and the container will scale, it keeps the image in proportion with the container, which is in proportion with the overall responsive layout. Alright, so do we have some problems here? Yes. If this is a large image and we keep on scaling it down using HTML and CSS essentially, it may not look good scaled down. Also, the browser is still downloading that large image anyway. And on a mobile device, this is not necessarily efficient. Alright, so what is the solution? There are several solutions that developers have come up with. Both of them require additional code. The first solution is called Adaptive Images, which requires some server-sided PHP code. The next solution is using a polyfill. A very popular polyfill for this is picture fill, and you can find out more about this and the URL below. Alright, rather than using, or maybe in addition to using, our target divided by context equals result rule, we can also deploy what is called a CSS grid system, which also might be called a framework. What these systems do is they enable rapid development and consistent layout for both our vertical and horizontal layout. They come with code and classes and instructions on how to use them. There are some very popular frameworks out there, and these actually work very well, especially if you have a lot of columns going on in your layout. Okay, I am looking at the skeleton framework here, and most of these frameworks are built on a 12-column grid at the 960 pixel width. Remember, in the past, developers used 960 pixels for many reasons. One of them is that it's divisible by most numbers, so it's easy to lay things out in grids. And here again, these grid systems or frameworks provide classes that you can apply to your code that automatically will give you the resizing and the responsiveness you need without having to do a lot of the work yourself. A grid system that is used in our text is columnar. Here again, it uses a 12-column grid, and you can find out more about this by reading in the book and also from the URL here. A couple other things that you really should be using in a responsive web layout. The CSS3 box sizing property. As you may remember, by default, borders and padding are added to the overall width. So if we have a width of a container and then we have some padding and then we have a border, our width is no longer the CSS width, it's actually bigger than that. And if we were using our target divided by context equals result rule, we would have to be calculating all that, and it just becomes very messy. It becomes very messy even if it isn't responsive. The box sizing property is used to tell the browser how to size up the width and the height. It will tell it that either the border and padding is included or isn't included. By setting the box sizing property to border box, And this is a CSS3 property, and you do need to use these vendor prefixes at this point in time. By setting the border box property, it says that it will automatically include the border and padding into your width calculation. So if your width of a container is 400 pixels, regardless of what you do to the border and padding, it will be 200 pixels from a calculation point of view. So this is very, very handy. This should be used in your web layout all the time. Another very handy thing that we should be doing is using either a reset style sheet or preferably Normalize.css. As you know, there are default margins, default paddings, default sizes that come inherent in many of the HTML elements. And when you're trying to do page layout, even if it's not responsive, these come into play and they may interfere with your calculations. By using these normalize or reset style sheets, what they do is they remove the defaults, the margins, the padding, they initialize sizes, any kinds of indents such as the unordered list. Normalize.css is an alternative to the reset style sheet that has been so popularly used. You can download it, and you can use it as a CDN, and there is more information on the website about this. Finally, you should be using the HTML5 shim or shiv. Not only is it useful in responsive web design, but in basic web development also. Here again, this provides support for browsers, actually for browsers that don't understand the new HTML5 structural elements. Here again, using the CDN is very useful, and notice we have it enclosed in our conditional comments. If LT IE9, if it is IE9 or less, then it will read this file. So this is useful. You don't necessarily want the browser downloading and reading code unless it really has to. So by using conditional comments, which only work for the Internet Explorer browser, you can direct the browsers to the code if it needs it and prevent them from reading it if it doesn't need it.